Hey guys, so this week we're going to be talking about volume of rectangular prisms. Volume is the amount of space a 3D object occupies. Just like area is measured in units squared, volume is measured in units cubed. Because volume has 3 dimensions and area has 2 dimensions. So I can say something like centimeters cubed. A figure is packed with unit cubes, even if not all the cubes are shown. They are still part of the volume. In my first example, I have a 2D shape. I have a 5 by 5 square. This gives me 25 units squared. So a 3D object actually gives it that height portion. So I have a length of 4, a width of 4, and a height of 1. Now, last year you guys learned the formula length times width times height. So if I do that, I have 4 times 4 times 1, which gives me 16 units cubed. The next one, I have a height of 2, a width of 2, and a length of 4. And again, if I multiply all those numbers together, 2 times 2 gives me 4, and 4 times 4 gives me 16 units cubed. Now, volume can be determined by finding the area of the base, which is represented by a big B, and multiplying it by the height of the object. Now, when you see the volume formulas on your star chart, you're going to see it for prisms as volume is equal to big B times H. That's for all prisms. Now, the way to determine which one you need, the big B tells you need to find the area of your base. To know what your base is, it's just how you label the base. So here I have a rectangular prism. My base is a rectangle. Now, to find the area of that base, to find the area of a rectangle, it's just base times height. Now, if I had a triangular prism, my base would be a triangle. And the area of my base would be the area of a triangle. So I would have half base times height. This is going to represent my big B, and then however long my shape is, or the height of my shape. The next one I have is a trapezoidal prism. Again, the base there is a trapezoid. So when I find the area of the base, the big B, my big B is going to represent the half base 1 plus base 2 times the height, and then times the height of your actual shape. So whatever your big B is, it just depends on the shape that you have. Again, with a cylinder, my base is a circle, and then I'm dragging that circle upwards. So going back to our example here, our formula is volume equals big BH. Again, for big B, to find the area of a rectangle is just the base times the height, and then times the height of my actual shape. So my base here could be the 8, the height could be the 4, and then my height of my actual prism is 3. So I have 8 times 4, which gives me 32, times the height, which is 3. So 32 times 3, we have 96 yards cubed. Now this one, again, you could use length times width times height, but again, we do want you to get used to the formula with the big B in it, just because that's what you're going to see on star charts. It's what you're going to see in the next few years that you have math. Now here I have an example and then a non-example. So an example using this with a cube, we know we have a base as a square. So if I find the area of that square, I know I have a 5 by 5 square that's being drug by 5 inches tall, or our height. So the area of that base shape is 25, and then times the height of the actual cube, 5, gives us 125. Now a non-example would be if I had this 2 by 7 by 13, where my base is that 2 by 7. Now here they got 9. And what they did, they just added those two numbers together, and that's not how we find the area. So this would be wrong. So let's go through some examples. Now, because this is a rectangular prism, I can pick whichever rectangle that I want to be the base. Now, if I had a triangular prism, well, I can't pick the rectangles that they have here because my base is a triangle, so I would have to pick a triangle. Like the trapezoidal prism and the cylinder as well, I can only pick the base shape. Because our base is a rectangle, I can pick whichever base that I want. So here my base that I'm going to pick is the 6 and the 9. So my base here is my 6 and 9. 6 times 9 gives me 54. And then I would have that 54 with a height of 4.5 centimeters. So 54 times 4.5. 5 times 4 is 20. 5 times 5 is 25, plus 2 is 27. Add a 0. 4 times 4 gives us 16. 5 times 4 is 20, plus 1 is 21. Here I have 0, 13, 4, 2. Now I have one place after the decimal, I have one place after the decimal. So my formula was big BH. So when I plug it in, I have the area of my base, which was 6 times 9, and then times the height of my actual shape, 4.5. And I get 243 centimeters cubed. The next shape here, again, you can choose whichever one you want to do. I'm going to pick the base as this 11 and 2 now. So the area of that rectangle that I'm choosing is 22. That's being dragged by 5.3 meters. So times 5.3. So again, my volume is big BH. Pick an area of the base that you want to find. So I did 11 times 2, and then times the height of 5.3. So 3 times 2 is 6. 3 times 2 is 6. 0. 5 times 2 is 10. 5 times 2 is 10. Plus 1 is 11. So I have 6, 6, 1, 1. One place after the decimal. So I have 116.6 meters cubed. Okay, here we got to work a little bit backwards. So it says a closed dresser is has a shape of a rectangular prism. The dresser has a volume. So here are keywords: a volume of 48 cubic feet. So it's giving us the total, and we're going to have to find one of the missing dimensions. It says it has a height of 3, a depth of 2. What is the width of the dresser? So I want to know this piece here. How long is that piece going to be? So I know I have a height of 3, a depth of 2, and I'm looking for this, and I know the whole thing is equal to 48 cubic feet. So we have volume is equal to big BH. I know my volume is 48. We can take this side as our base. So we have the 2 times 3. And then times our width here, or our height. 2 times 3 gives us 6 times h. Now to undo this, it looks like a one-step equation. So to get this h by itself, we're going to divide by 6. And 8 is equal to our height, or our width of our dresser. So we have 8 feet. And it's not feet cubed just because I'm looking for one dimension there.